All right. Hello, everybody. Welcome to day 23. We're finishing, this is the beginning of the 12th week of classes. As you can see what we have here, we have 2 more chapters to do. Chapter 15 has sections 1 through 8. Chapter 16 only has 7 sections, 1 through 7, but we skip section 4. So in essence, we only have, 6 sections there. So we have 14 sections left. And the days we meet this is the Thanksgiving week, which we're supposed to have class. If we need to, I'll be here. But I was hoping that this week is everybody catch up with all their work and all their tests. Because the only thing I was hoping to do in this week was review. Because this is your final. That's your final week. This is Thanksgiving. I was hoping for this to be nothing but reviews. So that means we're going to finish up everything these next 2 class periods. We're almost done with chapter 15 to begin with. We've already done the first 4 sections. So let's look what those were. Chapter 15. Section 1 dealt with addition and subtraction of polynomials. The rule there was combine like terms. Section 2 dealt with the product rule and the power rule of exponents. The product rule simply said this: if you multiply 2 numbers with exponents and the bases are the same, if the bottom numbers are the same and you're multiplying together, a shortcut is just add the exponents. If the bases are the same and you're multiplying them, just add the exponents. That's the product rule. A product means multiplication. The power rule says if I have an exponent number raised to a power, then a power to a power, you multiply those exponents. So that's what those rules tell us. And we have a whole bunch. That's when we went through all the properties of exponential numbers. There were 12 of them, and we'll do some more of those this morning because I'll make sure it's in your heads. All right, section 3. Multiply polynomials. We learned how to multiply. If you have 2 terms and they're both binomials, they both have 2 terms, we use the FOIL technique. But the FOIL technique only works when you have a binomial times a binomial. So 2 terms by 2 terms. What if you had something like this? The FOIL technique doesn't work here. So here we have to use distributivity. everything in the first parenthesis distributes to everything in the second parenthesis. And we'll look at a couple examples there. And then I'm also going to show you another way. It's called the rectangular method. And it'll make life much easier when we put this. All you have to do is remember how to combine like terms. So that's what we'll do a little bit of both of those this morning. Section 4. Dealt with special products. We didn't discuss these yet. I was going to go through those today. I'll make sure everybody knows how to multiply them together. Here we're talking about square binomials. In other words, if I had something like this and I square it, what does that mean? Product of different signed terms. In other words, what happens if I have the same numbers, but the signs are different? What happens there? And then we'll look at greater exponents. If I gave you that, how would you multiply that? How would you find that? Yeah, so for this first one, we're going to look at what happens when you have a binomial squared, what the signs are. Section 5 dealt with integer exponents and the quotient rule. Quotient means fraction. In this section, we're going to discuss when things have a power of 0, when things have a negative exponent, when a fraction is raised to a power and it's or raised to a negative exponent. And then we're going to look at combining all the rules. That's just because everything can happen. There's just mix them up. Section 6 deals with dividing polynomials by monomials. In other words, if you have a polynomial and it's divided by a single term, what happens there? Section 7 deals with dividing polynomials by polynomials. So we have a polynomial divided by a polynomial. And with this, we're going to discuss applications as well. Where would we use this? How would we use this? Why would we use it? And then the last section of this chapter deals with applications of exponents and scientific notations. That's what we're going to do. Again, we've done most of it already. We're just going to touch up some stuff and then finish up the chapter today. If not, then we'll finish it on Wednesday and then start chapter 16. My goal is to try to finish everything by the end of next week so we have time to go over and review what we need to review. Ready to get started? Let's get started. All right. Product and power rule. Remember what those were. If I have the same base, different exponents, I add the exponents. That's the product rule. If I have an exponentiated number raised to a power, then I multiply those exponents. This is called the power rule. What we also discussed last week or 2 weeks ago was if I have a product of terms inside of parentheses raised to a power, that exponent goes to every term inside that parenthesis. It doesn't work if there's a plus or minus inside the parentheses. You cannot distribute the exponent. This does not work. You can't, if there's a plus or minus inside the parentheses, you cannot distribute that exponent. Only if it's multiplication or if it's division. We can distribute that exponent. 3 squared is equal to what? That's 3 times 3 is 9, right? Let's throw in a negative. So negative 3 squared is what? Then what's this one? In parentheses, negative 3 squared. So which one's which? They both can't be the same answer because they're not the same equations. The exponent only belongs to its base. Is the negative the base of the two? No, the only thing that's the base of the two is that 3. The negative is on the outside. 3 squared is 9. As opposed to this, what this one means is negative 3 times negative 3, which is positive 9. This one is negative 3 times 3. Good morning. So you have to be very careful of where the parentheses are and where the exponent is. What's that going to be? Negative what? Right. Answer should be negative 9. Order of operations says do exponents first. I have to do this first. So the negative just stays out there. I have negative 3 times negative 3. That's what this says. Negatives are positive. 3 times 3 is 9. Negatives out there. Now I can combine these two. So the answer is negative 9. How about these two? What's that? Just 27? Is the negative included in this? The negative, what this really looks like is negative 1 times 3 to the third. That's what it looks like. Order of operations says do exponents first and then multiply. So this one is negative 27. How about this one? Yeah, because what this thing says, it's negative 3 times negative 3 times the base 3 times. Negative times negative is positive, times negative is negative. 3 times 3 is 9, times 3 is 27. They're both negative 27s. So what do you notice between these 4 examples? What are they showing you? What are they trying to simplify or signify? Why is that a positive 9? Why is that a negative 27? I understand why these are both negative because the negative's out in front. That's not tough one. But why are these different signs? Yep. If your exponent is even and you have a number outside parentheses, it will always be positive. If your exponent is even and your numbers inside parentheses, the base inside parentheses, it will always be a positive answer. If you have an odd exponent, the final answer will be whatever signs inside the parentheses. If you have an odd exponent, whatever the base is, your final answer will have that sign. If the base is positive and it's an odd exponent, it'll be positive. If it's an odd exponent and it's negative, the answer will be negative. With even, it's always, as long as it's inside the parentheses, it's always going to be positive. Be very careful when you do these things, because it's very easy to make a mistake and screw up along the way, which is why I'm going to show you a whole bunch of examples now of these. All right. Let's look at the first example. Now here's our first example. 5 times, open parenthesis, 2 times x squared times x cubed times x to the fifth, close parenthesis, raised to the power 4. Okay, so what's my first step? The 5? No. Order of operations is multiplication or exponents. Which one's more important? Exponents. Always do exponents first. So we cannot distribute. So that 5 has to stay in front. We have to get rid of the parentheses. How do we get rid of the parentheses? We have an exponent. What do we do with that exponent? It gets distributed to each term, each member of that polynomial inside there. So each element of what's inside the parenthesis, I put it in parentheses. Right now, we'll do this. I'm sure, and then we're going to look at the shortcuts later on. So everything inside the parenthesis is its own number raised to the power 4. What is 2 to the 4th power? 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. What about this one? What does this one become? What's the rule about power to a power? You multiply. That's the product rule, or the power rule, I mean. So 2 times 4 is 8. Same thing with these guys. 3 times 4 is 12. 5 times 4 is 20. Five times 6 is 30. 5 times 1 is 5, plus 3 is 80. X to the 8th, y to the 12th, z to the 20th. There's your final answer. Let me see here. If in first parenthesis is 3x to the third power, 4x to the fourth power, multiply together, what does that give us? What happens to the first parenthesis? Always ask you the same questions. You have parentheses. Can we do anything inside the parenthesis? Can we do anything inside the second parenthesis? So since we can't do anything inside the parentheses, we have to get rid of the parentheses. So how do we get rid of this first set of parentheses? Distribute the exponent. Very good. 3 to the third, x to the third. Remember, they're still multiplied. Same with the second one. You can't do inside there, so we have to get rid of it. So we have to distribute. 4 to the fourth, x to the fourth. And these are all multiplied. And you have to get rid of the parentheses. You can't do anything as long as you have parentheses, so we get rid of them, distribute. 3 times 3 times 3 is 27, x to the third. 4 to the fourth. 4 to the fourth is 4 times 4 times 4 times 4. 4 times 4 is 16. 4 times 4 is 16. 16 times 16, 256. Times x to the fourth. What can we combine? Can we do anything with the numbers? Can we combine the numbers? Multiply them, yeah. We have 27 times 256. 7 times 6 is 42. 7 times 5 is 35, plus 4 is 39. 7 times 2 is 14, plus 3 is 17. 0. 2 times 6 is 12, carry the 1. 2 times 5 is 10, plus 1 is 11. 2 times 2 is 4, plus 1 is 5. And add those. 11. So it's 6, 9, 1, 2, x to the third, x to the fourth. Combine like terms, the x's. Since we have the same bases, what do you do with the exponents? Add the exponents. 3 plus 4 is 7. And there's your final answer. Definitely do the homework assignments because it will tell you at what point you don't have to put the number into a number. If it was 4 to the 8th power, I wouldn't work that out. I'd say it was 4 to the 8th. But since they're small numbers, you can multiply these out. All right, so let's look at some more examples here. 2/3 raised to the power 2 times 2 to the third. Very good. So in this first one, I get rid of the parentheses by distributing. Since I can't do anything inside the parentheses, I have to get rid of the parentheses. So it's 2 squared over 3 squared times 2 to the 3. The second equation, is it, the first one's a fraction, is the second one a fraction? Every number is a fraction. It could be over 1. I just do that to make it look easier to look at. Because the rule is, whenever you have fractions and you're multiplying them, what's the first thing you do when you multiply fractions? What's the rule about multiplying fractions? Reduce. Can anything on top cancel with anything on the bottom? No. These are base 2s, these are base 3. So you can't reduce. Since you can't reduce, you multiply top by top, bottom by bottom. So 2 squared times 2 cubed over 3 squared times 1. So what do you do in the top one? How do you combine those two? Yeah, since you have the same base, leave it there, add the exponents. So since nothing can reduce earlier, nothing's going to reduce here. 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's 32. 3 to the power 2 is 9. Since that's an improper fraction, how many times is 9 going to 32? 3 times, with how many left over? Over 9. So the system, I don't know which one it'll take for sure, but in conventions of mathematics, you never leave an improper fraction as an answer. On this one? No, you only cross multiply if you have a proportion. If you only do that if we have something like this. Cross multiply only works if you have a fraction equals a fraction. Again, that's why I don't like to introduce single rules that only work one time, because the wrong application of the rule can mess up your answer. So that's why I like to always stick with the basic rules we can prove. Okay, let's look at another example. Can anything be done inside the parenthesis? No. So let's get rid of the parentheses. What do we do now? Yeah, distribute the exponent to each term inside there. So the 5 becomes 5 squared. What does the x become? And 3 squared. 5 times 5 is 25. What do you do when you have a power to a power? multiply. Over 3 squared is 9. And there's your answer. It's like the first example we looked at. Whenever you, inside the parenthesis, whenever you have numbers that are have an exponent, these numbers all had exponents and raised to a power. So what do you do there? Since it's an exponent raised to a power, you multiply these. 2 times 4 is 8. 3 times 4 is 12. 5 times 4 is 20. So whenever you have inside parentheses, if you have exponents on the outside, you have another exponent, multiply them. Same thing here. Here's an exponent to another, you multiply those. 3 times 2 is 6. Do that one. So we distribute. So the first one is a -5. It gets a square. The next one is an x squared. It gets a square. Both of these get a square. The negatives inside the parentheses. So what's -5 squared? Is it positive or negative? Positive because it's even. If the negative is inside and it's an even, it cancels. It's gone. So 5 times 5 is 25. Power to a power, you multiply. 2 times 2 is 4. And there's your final answer. About that one. So what happens in the first parenthesis? Yeah, the 4 goes to the 1 and the 3, so it's 1 to the 4th over 3 to the 4th times. Same thing with the second one. 2 squared x squared. Again, it's since we have a fraction multiplied, this other one's also a fraction. 1 to the 4th is what? 1. So yeah, 1 to any power, it doesn't matter. It's always going to be 1. So we don't have to worry about that one. So since it's multiplied, what we really have, since that's a 1, nothing happens to it. That's a 1, nothing. So what we really have is this. Since you're multiplying them, it's the same equation. Just everything's multiplied to everything. Since nothing cancels, we're good to go. Before we multiply them, we cancel whatever we could first. So 2 squared is 4. X2. 3 to the 4th is what? Yeah, look at it. You have the equation, you should get the same answers. 81, because it's 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 81. Like, remember, you can't do something in mathematics unless there's a rule says you can do it. Why? What is this one going to equal? Because the rule here is whenever you have a power to a power, what's the power of this one? It's a 1. 1 times 2 is 2. 3 times 2 is 6. 3 times 4 is 12. 5 times 4 is 20. So whenever you have a power to a power, you multiply them. Right, so that does it for that section. That was section 2 review. Section 3. Actually, do we do those? We do, oh, that's the next one. All right. Multiplications of polynomials. All right, we've heard whenever you have a binomial, in other words, something with 2 terms times something with 2 terms, binomial times binomial, we use what's called the FOIL technique. It's an acronym. So the x times x, those are the first terms. That's the f, the first f. X times x is x squared. That's the f. O, the outer ones. X times 5 is, they're both positive, so it's positive 5x. That's the outer. Then you have the inner ones. Positive, positive is positive. 3 times x is 3x. That's the inner ones. And then we deal with the last ones. Positive, positive is a positive. 3 times 5 is 15. That's the last one. That's why I call it FOIL. Combine like terms. Whenever you get rid of parentheses, always combine like terms. Whenever you get rid of parentheses, always combine like terms. So 5x plus 3x is 8x plus 15. So that's one way. Another way of doing it, but again, FOIL only works if you have a binomial. Binomial times a binomial. That's the only time it works. Another way we could have done the same thing. Remember, here's our final answer. Method 2. Distributivity. Remember what distributivity was? We have a coefficient, whatever's in front multiplies to every term inside the second parenthesis. Remember that? That's this distributive property. But in this example, I never told you what A was. A could be anything. A could be an equation. So what this rule says here, if you have two parentheses multiplied to each other, take the first parenthesis, that's your A term, and distribute it to each term inside the second parenthesis. So in the second, we have x times x plus 3. Then a plus 5 times x plus 3. So I take whatever's in front up here and multiply it to each term inside there. Do the process again. You have a coefficient, x times x, x squared. Positive, positive is a positive. X times 3, 3x. That's that one. Positive times positive is a positive. 5 times x is 5x. Positive, positive is positive. 5 times 3 is 15. We got rid of parentheses, combine like terms. 3 plus 5 is 8. It's the same answer. Okay, then you're saying if you get the same answer, why go through that second method? Because of this. You can't use FOIL technique anymore. First, outer, inner, it doesn't work anymore. So we can't use the first method, the FOIL technique. So let's look at the second. the distributivity method. Take the smaller parenthesis and multiply it to each term inside there. So we have a 3x squared, that's inside the second, times my 2x plus 3. I have a positive 4x times my 2x plus 3. I have a positive 2 times my 2x plus 3. So I take whatever's in front and put it behind each term. That's what I just did there. Now I distribute. Positive, positive, positive. 3 times 2 is 6. X squared times x. What is x squared times x? What power does this one have? So we have x squared times x to the first. What are you doing? You have the same bases. You add the exponents. 2 plus 1 is 3. So x squared times x is x to the third. When you multiply and divide, you change the coefficients and the exponents. When you add and subtract, you only change the coefficients. So positive times positive is positive. 3 times 3 is 9 times x squared. That's the first one. Positive times positive is positive. 4 times 2 is 8. X times x is what? X squared. Positive times positive is positive. 4 times 3 is 12 times x. That one's done. Positive times positive is positive. 2 times 2 is 4 times x. Positive, positive is positive. 2 times 3 is 6. We got rid of parentheses, so combine like terms. These are like terms. These are like terms. When we say like terms, what are we looking at? The variables, yeah. The letters have the same exponents. Or if you have a whole series of letters, they're all exactly the same letters and the same numbers on them. So the first one stays the same. It's 6x cubed. We have 9 plus 8. So we have 17 x squareds. We have 12 plus 4. There's 16 x's. And then a plus 6. And there's your answer. Okay, that's one way. You can distribute to the first term inside the second equation. There is a corollary. In other words, we can do the same equation yeah, this is another method of distributivity. The first distributivity, we took the first parenthesis and distributed inside there. In this method, you distribute everything from the first parenthesis to everything in the second parenthesis. Distribute each term in the first parentheses to each term in the second parenthesis. This is another distributivity property. So let's look at the first one. Multiply everything by 2x. So positive is positive. 2 times 3 is 6. X times x squared. There's 3 x's. Again, we're not done with the 2x. Positive times positive is positive. 2 times 4 is 8. X times x, x squared. Still not done because we have to do it 3 times. Positive times positive is positive. 2 times 2 is 4 times x. Because there's this x that goes inside there. So this 2x was multiplied each of those. It's finished. Now I got to do the 3. Positive times positive is positive. 3 times 3 is 9. X squared. Notice, instead of putting it at the end, I could put it under here. I can now line them up. So positive times positive is positive. 3 times 4 is 12. And there's 1x. Positive, positive. 3 times 2 is 6. I lined them up already. That's what I needed. So how many x cubes do we got? We got 6 of them. How many x squares? 8 plus 9, 17. How many x's? They're both positive. 12 plus 4 is 16. And then the 6. And there's your final answer, which was the same we got in our other one. So again, the first method we learned was foiling, but that only works when you have binomials times binomials. Anything else, you can't use it. You have to use something else. So I showed you 2 ways of doing distributivity. Here's the third one. The rectangular method. First example I used. 3 plus and plus. All right, so let's look at the first one we talked about. X plus 3 times x plus 5. Since each of these parentheses only has 2 terms, my rectangle will only have 2 rows and 2 columns. All right, so let's look at this first parenthesis. That one goes up here. So it's x and then 3. If it was a negative, if it was a -3, I'd put a -3 up here. Since it's positive, nothing changes. So that one goes up there. So this one goes down here. X is the first term and 5 is the second. What you do now is you multiply. X times x is what? X squared. X times 3, 3x. X times 5 is 5x. Five times 3 is 15. So we just multiply each of these rows and columns. And here's the first term, x squared. Add both of those since they're both x's. 5 plus 3 is 8x. And then the last term, it's a positive 15. Let's do another one of those, this time with a subtraction. How many rows, how many columns? Yeah. 2 columns and 2 rows. So remember, we multiply all these. So on the top row, we have 4x and a negative 3. 2x and a positive 5. Two times 4 is 8. X times x, x squared. Positive times negative is negative. 2 times 3 is 6, x. Positive times positive is positive. 4 times 5 is 20. There's only 1x. Positive times negative is negative. 5 times 3 is 15. It doesn't matter how you put them, because when you multiply these out, you only get one answer. So let's combine. So how many x squares do we have? We just have those 8. Here are the x's. We have 20 minus 6 is positive 14. Then the negative 15. There's your answer. The rectangular method is a lot cleaner because it's all there in the boxes. You just have to combine them and put the answer. The other methods, you're writing all over the place. All right, let's try a bigger one. X plus 5 times x squared plus 3x plus 1. And it doesn't matter which one you put on the top and which one you put on the side. It doesn't matter. It's going to give you the same answer. I'll show you. I'll do it both ways. We have x and 5 there. X squared, 3x and 1. It doesn't matter how you arrange it, whether this x squared plus 3x plus 1 is on top or on the side. Let's fill in the boxes. X times x squared gives me x cubed. X times 3x, 3x squared. X times 1, x. 5 times x squared, x squared. 5 times 3x, 15x. And then 5 times 1, 5. So you notice the top and the bottom corner are never touched with anything else. These other ones combine like terms. So we have x cubed. 5 and 3 are both positive, so the answer is positive. 5 plus 3 is 8. They're both x squareds. 15 and 1, they're both positive. 15 plus 1 is 16, so it's positive 16x. Has a positive 5. Let's do the second one then. X squared times x is x cubed. X squared times 5 is 5x squared. 3x times x is 3x squared. 3x times 5 is 15x. 1 times x is x, and 1 times 5 is 5. The top and the bottom are beginning and the end, so x cubed. And you combine like terms. 3x squared plus 5x squared. 3 plus 5 is, they're both positive, so it's positive 8x squared. 1 and 15 are both positive. 15 plus 1 is positive 16x, and then the positive 5. You get the same. So it's whatever method you, in other words, you can't go wrong setting it up. What I'm saying that for is, don't waste all your time figuring out how do I set it up. Just set it up. Let's look at a trinomial times a trinomial. Using this method is a lot easier. 4x squared minus 3x plus 2. Three x squared, negative 3x squared plus x minus 3. Yeah, it doesn't matter how you put them in there. Let's look at this. So again, it doesn't matter. If you want to, you can put the signs in front of them. I can put negative. You can make these are positive. You can put positive in front of there. You can put positive. It doesn't matter. Whatever method works for you. So this first one's negative times positive is negative. 3 times 4 is 12. X squared times x squared. Add the exponents, x to the fourth. We have 2 x's here and 2 x's, so we have 4 x's total. Next one, negative times negative is a positive. 3 times 3 is 9. I have 2 x's and I have 1 more x, so I have 3 total. Negative times positive is negative. 3 times 2 is 6 times x squared. That's x squared. Positive is positive. 4 times 1 is 4. X times x squared. There's 2 x's there, 1 x there, so it's 3 x's. Positive times negative is negative. 3 times 1 is 3. X times x is x squared. Add the exponents. 1 plus 1 is 2. Positive times positive is positive. 1 times 2 is 2. X. Negative times positive is negative. 3 times 4 is 12. We have 2 x's. Negative is a positive. 3 times 3 is 9. There's only 1 x. Negative times positive is negative. 3 times 2 is 6. Do y'all notice there's a check system going on here also? In our original equations, we have exponents 2, 1, and there's nothing there. 2, 1, nothing there. So when we set those up, look inside this answer part here. 4, 3, 2, 3, 2, 1, 2, 1, 0. So there's always a decreasing number of x's in each level. 4, 3, 2, 3, 2, 1, 2, 1, 0. If there's no set pattern like that, then you might have done something wrong with the adding of the exponents. Again, the first term is itself, so it's negative 12x to the fourth. Add the cubes. So 9 plus 4, so they're both positive, it's 13 x cubed. Look at all the squares. They're all negative, so the answer is going to be negative. 12 plus 3 is 15. 15 plus 6 is 21. They're all x squares. The x's, they're both positive, so the answer is positive. 9 plus 2 is 11. And then whatever the last term is. And there's your answer. Pretty straightforward. So that's how that works. Doesn't matter how big or how small. I mean, even if I gave you this equation, what if I gave you something like this? There is no wrong way of starting this equation. So how do you want to start this one first? Do you want to multiply the x squared times this first parenthesis? Or do you want to multiply the two binomials together? The choice is yours. How many of y'all just move left to right? Okay, let's do left to right. So the first thing we do is this. X squared, or there's a 1. 1 times 8 is 8. X squared times x is x cubed. Positive times positive is a positive. 1 times 3 is 3. X squared. So there's the first print. I just bring the second one down. Notice, because I have a multiplication of another term, I still have to have parentheses around this first part. All I do is multiply that inside there. So 8x cubed, 3x squared, 2x, and 1. Two times 8 is 16. X to the first times x to the third. There's 4 x's. Positive, positive is 2 times 3 is 6. X to the first x squared is x cubed. 1 times 8x cubed is 8x cubed. 1 times 3x squared is 3x squared. The top and the bottom just stay there. I mean, nothing happens to those guys. Combine the middle terms. They're both positive. 8 plus 16 is 14. And put that. So again, there's no wrong way of doing it. All right. So that's multiplying polynomials. The next section, section 4. Special products. Earlier, we learned if you have a term inside a polynomial, inside a parentheses raised to a power, and there's no plus or minus here, you can distribute. Things change once you put a plus or minus between the letters inside the parentheses. Because now what this means, since here's the exponent, what's the base? This whole big equation is the base. So what does that mean? This whole equation is multiplied to itself n times. So here's the first one. Also, if this was a minus, you'd have x minus y all the way through here. So it doesn't matter the sign side there. So the first one, let's look at x plus 2 squared. So what this one tells us is x plus 2 times x plus 2. You know, the first term is going to be x squared. So we have x times 2 is 2x, 2x. Take the first and last terms, 2 times x and 2 times x. 2x plus 2x is 4x, and then the last terms. I'm skipping the stuff that you can do it yourself if you want to, but I'm skipping the minutia stuff. I'm get to a point where I'll show you a shortcut. X plus 3 squared. X plus 3 times x plus 3. X times x is x squared. 3x plus 3x is 6x. 3 times 3 is 9. And squared. And then we'll do some minus ones. X plus 4, x plus 4. X times x is x squared. 4x plus 4x is 8x. 4 times 4 is 16. Let's do these with minus signs now. So it's x minus 2, x minus 2. X times x is x squared. Positive times negative is a negative. Negative 2x is negative 4x. Negative times negative is a positive. 2 times 2 is 4. X minus 3, x minus 3. X times x is x squared. Negative 3x is negative 6x. Negative times negative is a positive. 3 times 3 is 9. And we'll do the same thing with a 4. X times x is x squared. Negative 4x is negative 8x. Negative negative is a positive. 4 times 4 is 16. Is everybody okay where I'm getting these numbers from? Anybody lost? Now you notice a pattern here. First pattern, always look at the signs. If you have a squared term and you have a plus inside there, both signs of your answer are always going to be plus. If you have a minus inside there and you square it, the first sign will always be what's inside the parentheses. The second sign is always going to be a positive. So the second sign is always going to be a positive. The first sign is whatever's inside the parentheses. So what can you tell me about the signs in this one? What are the signs going to be in this one? There are only two signs. What are they going to be? Positive or negative? Both of them? The first one will be negative. The second sign is always positive. So now, what goes in the first and last terms? Let's look at these. What goes in the first and last terms? Well, we have, where does x squared come from? X times x. So that's going to be the x square of the first term. How does this become 4? From 2 to 4, from 3 to 9, from 4 to 16. What do I do there? I square the number. 4 squared, 16. 3 squared is 9. So 7 squared is 49. Why? Right. What you do here, this is going to be 14x. Because if you notice, the middle term is if you take these numbers, 4 and 1, multiply them together, and times 2, what do you get? 4 times 1 is 4, times 2, 8. 3 times 1 is 3, times 2, 6. 7 times 1 is 7, times 2, 14. How about this one? This first term comes from where? I square the first term. So if I square the first term, what do I get? 4x squared. If I took the first term, 2x, and I squared it, I took the first term and I squared it, I get 4x squared. That goes here. What are my signs going to be? Well, since that's a plus, remember the second one's always a plus. There's no thinking about that one. Since that's a plus inside the parentheses, it has to be a plus inside here. Now, what's the middle number going to be? 3 times 2 is what? Times 2 is 12. So take the first and the last terms, multiply them together. 2x times 3 is 6x, and double it. 6x times 2 is 12x. 2 times 1 is 2x, times 2 is 4x. 4 times 1x is 4x, times 2, 8x. 3 times 2 is 6, times 2 is 12x. And the last term is going to be this last number squared. 3 times 3 is 9. Let's do another one. Yeah, the first term is going to be 16 x squared. What's the last term going to be? The second sign's a plus. What's the first sign going to be? Yes, be minus. So the middle term? Multiply these together. Yeah, 5 times 4 is 20. Times 2 is 40. X. So 5 times 4 is 20. Times 2 is 40. That goes in the middle. So you think you're okay with this? So that's one condition for a special product. Is you have to practice these before, or else you'll forget about them. And do another one, or are you okay? Huh? Yeah, so the first one is 9 x squared. Yeah, the second, since that's a minus, it's a minus. 4 times 3 is times 2, 24x. The second sign's always a plus. Once you see it, it makes life a lot easier for you whenever you have to deal with squares. Now, when would you use something like this? If I gave you that. No, let's just look at this first. So what does this really tell us? Well, it tells us that we have 4 of these multiplied together. Right? So we could look at these as 2 separate equations. Because we can expand this one pretty easy. 3x squared is 9x squared. That's a minus, so it's a minus sign inside there. 4 times 3 is 12, times 2 is 24. And then a plus, 4 squared is 16. So it's going to be the same in both of those. The reason that I want you to do it the shortcut way is you're missing a whole bunch of other terms. Now, we learn how to do these. 9x squared minus 24x plus 16. 9x squared minus 24x plus 16. We're not gonna work this out, but I mean, if you had to, it'll go faster. You could do it with pencil and paper, but because of time restraints, I'm not gonna work this out. 9 times 9 is 81. X squared is x to the fourth. Positive times negative is a negative. 9 times 24. So 9 times 4 is what? 36. 9 times 2 is 18 plus 3. X squared times x is x cubed. 9 times 6, 54. 9 times 1 is 9, plus 5 is 14. So I know that's going to be the same. And of course, these get bigger. I'm not going to do those. But then you would just add these guys, add these guys, add these. But here, I don't mind you using a calculator at this point. So you just negative 24 is positive, whatever that is, x squared. So this line in the middle will be x squares, x cubes, x's, and constants. All right, so that's the reason we learned the shortcuts for that way. Okay, that's one. That's if we have a perfect square. What if we just do it the other way now? We have the same numbers, but different signs in the middle. This is another one of the specials. This is called the difference of two squares. Let's see what happens here. If we multiply these out, let's use, keep it clean. Let's use the rectangle box. So we have x and y, x and negative y. X times x is x squared. X times y is xy. Negative y times x is negative yx. Negative y times y is negative y squared. So we have x squared. What happens with these guys? What happens to the middle guys? They cancel. XY and YX are the same thing. Commutative property of multiplication. So those cancel because they're the same numbers, different signs. And then y squared minus y squared. So what this rule tells us is this. Now you see why they call it difference of two squares? If I have the same numbers but different signs in the middle, and I multiply them, I have two squares with a minus. So it's a difference of two squares. So what's that one going to be? All this one says is take the first term, square it, take the second term, square it, and subtract them. Take the first term, you get what? Square it. X squared. Take the second term, 3, and you square it. What do you get? And subtract them, and there you have it. As long as the numbers are the same, only thing different are the signs. We call them conjugates. Conjugates are whenever you have the same numbers, but the only thing different is the sign between them. This rule here tells us when you have that, take the first number, square it, take the second number, square it, and subtract them. And that's all you have to do. Okay, what's that one going to be? Very good. Take the first term, square it. Take the second term, square it, and subtract them. But everything else is gone. How about this one? Are these conjugates? Yeah, they have the same numbers, only thing different are the signs between them. So they're conjugates. What's the final answer going to be? Yeah, 4x squared minus 9. Because what is 2x squared? 2x squared is 4x squared. 3 squared is 9, so we have 4x squared minus 9. How about this one? Very good. Yeah, just take the first number, square it, take this number, and subtract them. So if you get these things mixed up in your head, what's this one going to be equal? This is the last section we talked about. This is not this one. This is not difference of 2 squares. So what do you do in this one? Nope, you can't. If there's a plus or minus, you can't distribute. We just talked about these a second ago, guys. We just did a whole bunch of these. When you have a term squared, think about what you do. What's the square of the first term? 4x squared. The sign's a minus. And the second one's going to be 9y squared. Because you have to square the 3y. 3y times 3y is 9y squared. 2 times 3 is 6. Times 2 is 12. X times y. The whole middle part? Yeah, that's half. That's the middle. That's the guts. But you're right. You did the beginning and the end. That's the start. You're right. Because that's all we did in this part here. Whenever you have two equations and you have different signs, the middle terms are canceled. So all you're left with is the first term and the last term subtracted. But when I have a perfect square, I had to square the first and last. The second sign is always a plus. The first sign is whatever's in here. Then take this number times this number times 2. So 2x times 3y. 2 times 3 is 6. X times y times 2 is 12xy. So those are the special operations. So you have to practice those because it's easy to get them mixed up. Have a little cheat sheet next to you. I asked you from day one, always keep the formulas on a separate sheet. Section 5. Integer exponents and the quotient rule. Okay, we talked about exponents, we talked about quotient rules and stuff like that. What's this one going to be equal? You have to be careful. Is that negative part of that exponent? No. The exponent is only touching that 5. So that negative stays out there. How about this number? What's anything to the 0 power is what? Is 1. So what's the answer here? Where's the exponent touching? It's only touching the 3. So this is anything to the 0 power is 1. The negative's out in front. If I had that, what do you get? Right. Because anything to the 0 power is 1, that becomes a 1. 5 times 1 is 5. You can never have negative exponents in your answers. If you have a negative exponent, the way you get rid of it is doesn't change the sign of the answer, it changes the location of the number. So what this means is just move it, since it's on top of the dividing line, I move it to the bottom and drop the negative. Flip, right, yeah. So if I had that, what would the answer be? Does the 4 have a negative exponent to it? That negative exponent only touches the x. You're consistent. You've been doing that all along. You've been getting that coefficient mixed up. The only time you ever can combine it we had something like this. So what would you do there? First off, I get rid of the negative exponents. So that's a negative exponent. So that means it goes to the bottom. This negative exponent, that equation goes up on top. Now I distribute 2 squared y squared, 4 cubed x cubed, which means 2, that's 4 y squared, 64 x cubed, the 4 goes into 4 once, 4 goes into 64 16 times. There's your final answer. You're not done until it can be simplified all the way down to its smallest part. Because 4 and 64 are both even numbers. They both have at least a 2 in common. 2 goes into 2, 4 twice, and it's 32 times. And then simplify, always keep on simplifying your answer. What if the negative exponent was for an entire fraction? What would you do there? Because all this negative here does split it, as you said. So the final answer would be y to the n over x to the n. Distribute. So what would that answer be? Okay, so it has to be flipped. So it's 4 over 1 to the power 2. Because that flip just gets rid of that negative sign. And distribute. 1 to anything power doesn't matter. 4 squared is 16, and there's your answer. How about that one? Very good. Right. Very good. What would you do with this number? Let's make it squared. One over 4 to 2, which is 1 over 16. Because yeah, whenever you have a negative exponent, it has to be a flip. Let's look at some more examples of negative exponents. There. This one becomes what? How do you add fractions? Or we can use the butterfly method. Five times 1 is 5. 2 times 1 is 2. 5 times 2 is 10. And there's your answer. I love the butterfly method. It saves me a lot of time and effort. How would you write that equation? Nope. Does the 7 have a negative exponent? Oh, so it just stays there. This one has a negative exponent, so it goes in the bottom. There you have it. Or you just only change the parts that have the negative exponents. How about that one? That one doesn't do anything, it just stays up there. So this one goes on top. How about that one? Only move the ones at negative. You can't do anything until you get rid of the negatives. So since this is a negative, it can't be on top. It's got to go on the bottom. Simplify that one. So there's the dividing line. So which ones stay where they are? The 4 and which ones do not have negative exponents? Z. Everything else has negative exponents. They have to move. So that one, X has to go to the bottom, drop the negative. The Y goes on top, drops the negative. But it has a negative exponent. It has a negative exponent. You cannot have a negative exponent. You're just answering all the questions. Okay, this one. Okay, so what moves? Pretty much. Yeah, so these both have negative exponents, so they go to the bottom. These two go to the bottom and change exponents is positive. These go up on top. Drop the negative. We're not done yet. Two to the second is what? Three to the first. The variables. But now look at these guys. What do we have left? Aren't they the same bases? There's 4 of them up here and 3 of them down here. What do you do? Because they're opposite signs, you would subtract the exponents. Let me show you why you because what you have right now is x plus y, x plus y, x plus y, x plus y. Those are those 4. On the bottom, you have x plus y, x plus y, x plus y. Whenever you have the same bases, different exponents on top and bottom, always subtract the larger minus the smaller. Since there's more of them up on top, I'm going to subtract them up here. 3 of them cancel, so I only have 1 left. If I had x times x times x over x times x times x times x times x, whereas if I had x cubed divided by x to the 5th, since there's more x's on the bottom, I subtract 5 minus 3. Why do I put a 1 here? Yeah, because I took these 3 and put them down here. So I took that away, so there's 1 up here, right? So as I subtract, I just remove those. There's a 1 on top. There's 2 more x's on the bottom. So that's whenever you have the same terms top and bottom, just subtract the exponents. Okay. What if I give you this? But yeah, but you subtract it from where the bigger one is. So what's your final answer? These are bigger, so this has to be 8, 5 minus 4. That takes care of that one. This one's bigger, so it's m 10 minus 9. That takes care of that one. What do we have left on top? 1. 5 minus 4 is 1. 10 minus 9. So there's your answer. Okay. How about that one? What happens to the top? You have parentheses. You have to get rid of the parentheses first. What does the top become? No. 3 to the 4th would be 81. But no, since we have threes are the same basis, let's not multiply. Say that to the very end. How do you get rid of the parentheses first? Okay, there's not much to distribute. This is 3 to the 4th to the 2nd. You won't see, it's not going to change on the board. You have to look at your notes to see what the rules are. What do you have to do to get rid of the parenthesis up on top? What's the rule here? You have 3 to the 4th, all that to the 2nd. What's the rule? How to get rid of the parentheses? Nope. What's the rule there? When do you add exponents? In your notes, it helps if you use a highlighter to separate where all your notes are, because right now you're looking at just a bunch of white sheets with scribble on it. You don't know what you're looking for yet. You have to get a highlighter and highlight all the rules, all the examples. We covered it today. I mean, in the last 2 hours, we covered it. Very good. Power to a power you multiply. 4 times 2 is 8. You have the same bases on top and bottom. Different exponents. So what do you do there? We add them. What do you do when you divide? If you have the same things on top and bottom, what do? Do you add them or do you cancel them? So what do you do here? If you have same numbers on top and bottom, different exponents. Subtract the exponents. The larger minus the smaller. The answer is 3 to the 5th. It's just not asking you to go any further, so leave it like that. No, I said if the numbers are quick and easy, because now you're looking at 3 times 3 is 9. 9 times 9 is 81. 81 times 3 is 243. Yeah, I mean, you could, but it's just that this means nothing unless you can get to this. This shows me know the rules. All this shows me is if you went ahead and did all the numbers and you just calculate and print it out. Doesn't show me anything. So don't jump to that at the very end. I need to see the exponential answer. The rule of thumb is this: if the question starts as an exponent, it will want to see the work as exponents. How about this one? Very good. Very good. I don't know if everybody did catch that. We have the same bases. If you have the same bases, what do you do with the exponents? Add the exponents. Okay, we're not done yet, because we still have parentheses. Then you get rid of the parentheses. Very good. All right, simplify that one. What's the first thing you have to do? How do you do that? Yep. Inside the parentheses, go ahead and just change the negatives to positives. So the 6 stays where it is. The 7 goes up on top, so it's 6 times 7. The y has a -4, so it goes to the bottom. Z. Six times 7 is 42. You're not done yet because you still have parentheses. What is the answer, final answer going to become? How do you set up the final answer? (42 to the power 2). Just distribute that. What about the bottom? What goes on the bottom? So what do you get? Very good. Power to the power you multiply. Those are the answers. That is your final answer. 42 to the second power. 4 times 2 is 8. 3 times 2 is 6. Power to a power you multiply. Learn these rules. I mean, if you don't color coordinate your notes, you're just waste your time looking for where you are. Have one color to mean examples, one color to mean definitions, one color to mean rules or properties, so that when you're flipping through, you know what you're looking for. This one. What's the first thing you have to do? So what are I write? Get rid of the negative exponents on the parentheses. Flip those. What happens on top? What happens on the bottom? What? So what tell me what to write? Tell me what to write. 3x to the power 4. Anybody agree with that? I don't. What happened to the 3? Isn't that inside the parenthesis? Doesn't it get any of that? What this is 3x squared times 3x squared. What is 3 times 3? Every term gets that distributed. Everything inside the parenthesis gets distributed. Same with the bottom. Nine and 6 both have the same in common. They both have a 3. There are 4 x's on top, 1 x on the bottom, so I subtract 1. So I don't like it when students just bobblehead. When you're doing these example questions, please do them on your own and then look at what I'm doing. Don't stop and look what I'm doing, because all the questions I just asked 5 minutes ago should have been answered straight up.